spices and stuff. We do this every day. It's good.
I love camping. I love constructing things kind of before you go camping. You know, it's like, oh, we need this, just get some snakes. I love it.
I love starting fires. Like,
Oh, yeah.
Setting it up, stacking. Let's go.
So as expected, we've had massive attrition, and that completely doesn't surprise me in any way, shape, or form. One of the reasons I thought about taking attendance up front, but I really don't care, and I have this strange vision in the future of doing this all over again, because people are going to be like, oh, shit, that's really bad, I missed it. But I did put all of the other classes up on YouTube, not one like, but I've had like 40 plus views on each one, so it's like, it's a little depressing, but you know, if you
40 people pass.
if you end up going to my YouTube channel, could you please like one of the videos? That'd be really great, and would make me feel like I'm not wasting my time. So if you look in your book under unit testing, erase that section. Don't do it like that. Yuck. Do it the way I'm about to show you. This is a custom presentation that I wrote when I first started working here at IGT to help teach my team that I work with how I unit test and how to approach unit testing from my perspective. I've also butchered this up, and I did it at Django conference and all this kind of stuff. But I'm going to go through this, and we're going to have fun. Any questions before I start? We covered objects last week.
Organization. Right?
Yeah. Okay. So be it, Jedi. You want to hit the space bar for me there? Or is that too scary? You go, all right, outstanding. So we're going to talk about Python, what units are and what a unit test is, assert, what a testing workflow looks like, some tips. Hopefully we'll get far enough to deal with mocks. And if we get really far, I'll show you the bit that I wrote on Django that you're probably not ready for, but next week we're starting on Django, so hopefully you've been doing your homework.
Homework?
Yeah, if you don't mind. So, yeah, this is a little basic. As you know, you can just type Python from a prompt, and you can do all kinds of nice stuff in your command window. So hopefully you're used to typing Python and then doing some Pythonic things. Cheers here, too. I hope. Next, please. Thank you very much. You can also, we covered most of this, you can save it in a file, and it could look something as basic as this. The one piece I talked about previously that I'm going to emphasize here again, if you put this statement here at the bottom of your Python file, it will then execute this function upon calling. So here, to run this MyPython file, you just type this, or you can type the whole path. Or you can also type Python space in the path of the file. All three of those will run this file. If you were to take this out and run this file, it would do nothing. It would load, but it wouldn't actually run anything, because print hello is actually in a function. Right? So we have to call this function in order to get it to actually run. So if you put this at the bottom of that Python file, it will execute this function when starting.
Is that mandatory to keep it bottom, or you can call it anyway?
Stylistically at the bottom.
So in order to have a function called in a class in Python, you have to put this kind of construction at the bottom of your class.
This is just to get the entire file to execute. Right? If I want to call this file and have it say hello world, unless I put hello world on this line, because then it wouldn't be inside a function, right? I can just have Python say hello world. Right, I can just do that. But if it's in my function, right, nothing happens.
unless I specifically call my function, at which point it says print hello world. So if inside,
this my Python file, I have this function, in order to get it to call from a command line, I need to call it this way.
Could type that into a command line. Name equals.
If I did, it would do nothing. This is all inside this my Python file. And I'm going to cover this piece again here as we build unit tests. Good, good, good.
Kind of like a constructor.
No worries, dude. I'm sorry?
Kind of like a constructor. Forces a function that
When
executes when the file is.
This is implicit in this. Python then calls this file. When Python calls this file, unless there's something to execute, it's not going to execute it. So this is the proper structure. When I call this file, by definition, Python looks for main. If it's there, it calls it. Now, we happen to name this one main, but this could be my function name goes here, at which point that would be called there. We'll do more of this because unit tests are the same way. Yeah, I've done this with you already, but hopefully by now you have the hang of this. Beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated, and readability counts. Those are really, really, really super important. The other thing off of this list that I'd like to read to you, to say that code is Pythonic is to say that it uses Python idioms well, that is natural or shows fluency in the language, that it conforms with Python's minimalistic philosophy and emphasizes on readability. In contrast, code that is difficult to understand or reads like a rough transcription from another programming language is called unPythonic. All of my code is Pythonic. Everything I do in my reviews of any code that you submit to me will be to try and make your code more Pythonic. Java-like code in Python will run, but it will not be Pythonic. Right? It's a little arrogant, actually, but in my experience, it's pretty much true. Python's the most readable language I've ever encountered. So, some examples, right? We've covered what a list is, so here's a nice list. Now, oh, good. And this should all be on the same line. So if I want to iterate across this list, I go for item in my list. If not, item mod 2, even list, append item. This would give me a list of all the even numbers. Hopefully by now we've had enough Python. We know for, we know if. Modulus you may or may not know. This is remainder from division, if it has a remainder. Okay, so this is very Java-like. Yeah, that's how everybody does it. In Python, this all needs to be on one line. I looped it here because I couldn't fit it on the slide. Even list equals bracket item in my list if not item mod 2 bracket. This is called a list comprehension. This one line is equivalent to these 3 lines. This is very Pythonic. This is very not Pythonic. List comprehension. It's equivalent to a generator. I talked about this briefly in our lists discussion. Still haven't even gotten to unit testing yet, and everybody's quiet. Not a good sign. So what's a unit? The smallest testable part of an application. Could be large, could be small, application, object, method, or function. Make your units small and bask in the readability of your code. If you have a function or method that's more than 10 lines long, you really should reconsider that. Those units are too big to test. If you're going to write unit tests for that, it's going to take you a very long time. If you have small units, Your unit tests are going to take you very little time and actually be extraordinarily helpful. Small units.
Could you go back to your example that you
I'd be
had?
happy to go back to my example that I had previously.
So, in the example that's there, it looks like it's combining a lot of stuff, which is what you see in the upper part, which seems like that actually makes it a little bit harder to understand everything that this is doing, where over there it's, I think, a little bit more clear.
I would suggest only because you have not worked with Python extensively. For me, this is a fast read, and this is a slow read. Why? Because it is. The flip side of that, list comprehension's RAM usage is dramatically better than this, like light years on a different planet as far as actual CPU RAM usage, because this is specifically designed to generate a list versus this for loop may or may not do something out the other end. This if statement may or may not do something out the other end, and this append, right? But I don't even have an append here. Where's my append? There is no append. I'm creating a list by definition. This is a list comprehension. I'm manufacturing a list. It's a list generator. So, and how do I know about this? Veterancy. Just learning about how Python is supposed to work. Happiness?
So a veteran would understand all of this, but a relative newbie is totally blown away by it and can't really comprehend it.
If you submitted this code to me in a code review, I would flag this as unpythonic and write this for you. It only takes 2 or 3 times before you recognize that, hey, I should use a list comprehension here. Especially when I'm appending things to a list, really likely you're going to use a list comprehension to do that. Or a generator, which we haven't covered, which is a semi-complex thing. He says,
I can do
So you're using the modulus operator, if not, I would expect if not mod 2 equals 0 or something like that.
no need.
So is that like saying if there is no remainder?
Right. None is false in Python.
So it's because it's 0. 0 is false.
You know what I say? None, 0. Sorry. Yes. And that is very Pythonic.
Got it.
Okay, what's a unit test? A method by which individual units are tested to determine if they are fit, ensures code meets design specifications, and behaves as intended. What does fit mean? Write unit tests so you until you can't think of any other possible input-output. Bad input, good input, everything that is possible to come in and out of your function test. Test every single line of code. Nothing you created is to be missed. Typically, we don't test logic we didn't write. If I'm using URL lib, for example, and I want to call a URL, I want to call google.com, right, and read what it gives back to me. I don't need to test URL lib. That's an external third-party library. Actually, it's built into Python. I don't need to test any of that. I can assume that that works. Any logic you create, if you put 1 + 1, you have to test that. Both good and bad input. Is the output exactly what was expected? Ultimately, can you change something small and see tests fail? This is really the catch. If you can go into your code and enter something and your tests fail, that's good. That means you've done a good job in general. Integration versus unit testing. What I've seen here, a lot of what I see here is what I qualify as integration testing. Integration testing means I'm testing front to back. I have a whole bunch of stuff run inside and it gives me back a value. So I'm not just testing my unit, I'm actually testing a bunch of my back end, whether that returns correct or not. And that's not really right. So how do you get around that? How do you not test everybody else's stuff and still test your stuff? Anyone?
Principal encapsulating?
Principal encapsulate. I like that.
Encapsulate.
That's like units. I like that answer.
Standalone test.
Standalone tests Yes, how do you do that if you call third-party modules inside yours?
Like a harness?
Harness. Ooh, I'm enjoying this. That's a wrapper and kind of sort of heading in the right direction. Try except. Definitely use try except I actually test for exceptions. So yes. Drum roll please. Ah, there's the word I'm looking for. The word is mock. M-O-C-K. I mock you. Oh well. So a mock is a fake, not real. I replace the things that I didn't write with something fake. Da, 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 da. Python is stately. Python is stately. That means I can change things that have already been instantiated on the fly. So we'll show you how to do that. We'll get to that. All right. Yes, let's do this in order. Find your problems early. Test must pass before review and especially before push. Facilitate change. Tests reflect exactly what the code is supposed to do. Therefore, refactoring and expansion is less dangerous. Documentation. Read the test before the source and you will know what to expect. If you read any of my code, start with the tests. It'll make everything go a lot easier for you. And I'll show you some of those coming up here shortly. Design. Unit tests can literally be a specification document, right? Prod comes to me all the time. I want to build this feature. It's like, okay, what are the tests for that feature? To them, that means this feature includes A, it includes B, and it includes C. That's exactly what my tests would do. Does it include A? Does it include B? Does it include C? Tests, same. So I'm trying to move my prod guys toward using the word assert in their definitions, because if they use that word, we're all on the exact same page for a product. Synergy. By thinking in units to test, software is very modular and therefore easily reusable. Don't repeat yourself. If you use small units, you can use those units over and over and over and over again. If you write really big units, that's it. They're one shot. They're specific for what you're writing. Bad style. Small units, reusable, good style. All right, small units equals sane software. 100-line functions are insane. Don't do that. Small separate units also facilitate readability, right? If I'm reading small units, it becomes much easier for me to figure out what's going on. Small units, please. Unit testing does not catch everything. Unit testing complements integration testing, right? I'm going to test my little pieces, but then ultimately before I push, I am going to perform integration tests, front to back. Does everything actually perform the way it's supposed to perform? Can you write automated tests to do this? Heck yeah. Does it take a while? Yes, it certainly does, but it is a good thing. Time. Many more lines of code for the test than actual logic. To test both good and bad input requires 2 sets of tests. Typically, my tests are 4 times the number of lines of code as my actual code. So it typically takes me twice as long to write my tests as it does the actual code. But when it leaves my desk, it don't come back to my desk. So good. Let's start hacking at some tests here. So this is super basic. This is pretty much the same thing we were talking about earlier. Is odd, given also very, 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 very good docstring. Yes, up to Google standards, they would approve this function. Happiness. Given a value, determine if the value is odd or even. Args, value. A numeric value to be evaluated as odd or even returns a Boolean, true if the value is odd, false if the value is even. Raises type error if the value is not a numeric type. Very complete, tells you everything you need to know. If you mouse over this in Eclipse or any of your other IDEs, it'll show you this docstring so you know what's going on. Now the hard part, return value modulus 2 equals 1. If it does, this is odd. Questions? I hope not. I was going to be worried. Answers? What do we want to test?
If it works.
If it works. Fatal. 1 red X. Next. The return, okay, yes, we are going to test the return value. I completely agree with you.
Test if it throws a type error.
Okay, we're going to test to see if it throws this type error. Oh, wow. You guys are going to kick yourself. Okay, if we give it an odd, we get back true. If we give it an even, we get back false. If we give it a string, we get back an error. 3 tests. Now, before I show you those tests, it's going to be full of this word. Assert is your friend. Assert runs a bunch of my life now, actually, I think, in terms of assertions. The most important word in unit testing, state a fact or belief confidently and forcefully. The company asserts that the cuts will not affect development. These are the most typical asserts that you'll see. Assert equals, not equal, true, false, is not, is none, is not none, in, not in, is instance, is not instance, not is instance. Yeah, what did it say? Hopefully you're understanding assert equals. Do these two things equal? Assert true. Is this Boolean true? Okay, so now here's the test for our modulus 2. I'll just let you read. Okay, a couple of things before we jump into the code itself. The function name, actually this is a method name, the method name is extremely explicit, more explicit than you would be typically in any kind of normal coding environment. Why? If I do a test runner, that test runner is going to throw an error. That error is going to include the name of my function. If my function name is extremely explicit, when it errors, I know exactly what's wrong. Same thing for the docstring, except I use a slightly different method. I always, 100% of the time, start with the word assert. Now I can put it in the middle, so probably 99% of the time. But most of the time it starts with the word assert, because you say, this is what I'm testing for in this test. So let's start at the top. We'll talk about the class here in a minute. I'm going to start with this first function method. Test even number returns false. Assert even numbers result in a false response. Test value equals 2. Result is odd. Test value. Self-assert false result, right? So I say, here's what I'm going to give you. Run your method, function, class, anything. Run it. Then test the results that you got back from your method, function, class, whatever. Did it work or did it not work? Test odd number returns true. Assert odd numbers result in a true response. Test value equals 3. Result is odd. Test value. So assert true. Result, right? It's supposed to be odd, 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 odd. False because it's even. True because it's odd. Now we'll go one further step. I'll talk about this in a minute. Assert passing an inappropriate value causes an error. Test value, quote 3, unquote. This is a string. Strings don't have modulus. It doesn't work that way. Okay, so with self-assert raises, and here's the error I'm expecting, a type error. And then I call it with this bad value. And I expect it to throw this type error. All 3 of these pass 100%. This is definitely a good test. I wanted to talk about this pylint. I also do it up there. Lint cleans your code, makes sure that you have it stylistically correct, close to PEP 8 typically. I disable this sometimes if I'm using like long function names are not stylistically appropriate, so lint will kick. If I put this in there, lint won't kick anymore. That's all this is. All right, now.
So it's okay to violate the coding conventions.
It's not okay, but it is
Test
okay.
In the test cases.
In test cases, definitely.
Yeah.
Definitely. A lot, actually. So anyway, good times. Method, class. All right. All of this is encapsulated inside a unit test case class. Very much like Java or ActionScript or any of the other basic languages. If I'm creating an object, I can give it a parent. What kind of object is this? In this case, we're creating a unit test case object. That object has a bunch of methods inherent to it, but we're using it simply to run these tests.
How does isOdd get to this test?
The import's at the top, which you don't see. So it would be from my file import isOdd.
Okay.
Would that be a single test file where you do just the isOdd test? Or do you generally have like...
I'll get to that. I have a slide specifically for you.
So is this the only line you use inline command?
Say-
Is this the only time where you will use inline command?
Don't make me use inline comments, but you're talking about for these.
Yes.
Yeah, those are not inline comments. Those are lint
Sure.
specifics. That's the way you do it. So yes. Okay, so he's all like, you said not to use inline comments. You're right, I told you not to use inline comments, so you're right.
So these tests don't actually say in the name that you're actually testing isOdd?
They could. In fact, that might be a good idea, but it really depends. Because I don't need to here because the whole thing is testing isOdd. So,
I guess usually we're testing classes and individual methods or something.
so yeah, and a little creativity is fine. Just make sure that it's pretty much obvious what you're testing. Good, really great question. Okay, so I showed you use unit test class. Fill your class with functions starting with test. I showed you that previously, but I'm going to show you again. They start with the word test underscore. This is really important. It is not required, but if you don't follow this convention, it is possible your test won't run because most test runners are looking for test underscore as the start of your function name, method name, sorry. Test names should directly reflect their purpose. Test docstring should begin with the word assert, doing stuff every time. Try setup and tear down. I'm trying to decide whether I showed this to you earlier, but a lot of times when I run a set of tests on a class, I need that class set up a certain way every single time. And the way you do that is you use setup. And it'll run that setup every time before it runs every test. It'll also run teardown after it runs every test. So for example, in Django, a lot of the time I will create an object, database object. And when I'm done, I'll need to remove that database object. Otherwise, the next test will use that object, which is not good. So clean up, set up and clean up. Set up, tear down. Really good things to have in your head. Write your main code after you have written at least the basic tests. Express where you are going before you go. This is the foundation of test-driven development. I like to write my tests first because most of the time I know what I'm going for. For example, in that modulus thing I showed you earlier, it would be very simple to write the tests up front. I know even is even and odd is odd and error is error. So I can write those tests first. Then, as I'm going, all those tests are red until I make my function work properly. Then all those tests go green and I'm ready to submit. Every test should be standalone, one behavior, one test. This is where setup and teardown comes into play. because each individual test should stand alone. No test should depend on any other test. That kind of breaks the idea if tests depend on each other. Okay, so now this is full. This is actually pulled from one of my routines, and it shows you everything associated with running a standalone test. This file will run by itself. You just type whatever we name it, which I didn't give it a name here, but you type the file name.
Word user session.
Did I? Yeah, that is it. Sort controller test pod. You call that file, it runs this. By definition, main inside a unit test will start a test runner and run this through. So, starting at the top, doc string explaining what this document is, followed by your name. Always sign your stuff. From bwalk, swerve, import, swerve controller. Here, I'm doing an import of the piece I'm testing. I also import mocks, which I set up right here. I don't actually use here, but oh, I do use it here. And import unit test. And here's unit test. Okay, so now if I was to call this file, it would run my unit tests. It would start here with swerve user session test. Would run the setup before running the first test. Would set up self.mocks equal to mocks.mocks, or like what's a mocks. I'll get to mocks in a few minutes. Don't panic on mocks. Self user ID equals test user ID. And that's a constant I set up here. Swerve user session, swerve controller, dot swerve user session, self user ID. So this is the class I'm going to be testing, and I'm going to test it over and over again. So I simply set it up so that all the tests have it available to them. When I'm done, I need to unset my mocks. We'll deal with this later. Nothing else happens here, but this runs after every test. So let's look at this test that we run here. Test instantiation of the controller results in a proper object. So here we instantiate, right? Swerve user session is equal to session controller. This is obviously a class. How do I know? Yes, camel cased, with the first letter being uppercase. That means this is a class, so I'm happy with that. I pass it a single argument. I want to check and make sure this is actually an object. So self assert is instance. Self swerve user session, yes, it's an object. We're going to do more, but I wanted to show you this is a complete file. This would literally run. You put it in your system. I know you don't have this module, but you can pick any module you'd like and put it in there and test it. And I did send this all to you, so you all have this file. Yes?
So does any class that extends object, will that return true for that testing is instance?
Yes.
Okay.
This is a lame test, just trying to get the idea across.
I have a question on the last time we talking about the underscore capital init underscore.
Yeah.
Is that one will get running inside the main or?
Does that run? Is there underscore init that runs here? The answer is yes, but we don't touch it. Every object has that. It definitely exists. We're not using it here, but it exists inside this object, yes.
So what state is it called inside the main before when the object creates?
When is init called? Yes, when you instantiate the object. Okay, I got all the answers today, apparently.
Why are you passing that self.user ID inside as an argument? Why can't you pass it directly as test underscore user ID? Is it something that is?
No, it's just in case I'm using it later. And the way I would use this is I should check this object and see that this user ID has been used or attached properly. So to have it available to you for testing is good. Also, I'm not worried about object sizes in tests, so I tend to just throw everything that I would use up against that object in case I want to test against it.
And you said the setup and teardown method function that will be run for each and every test, right?
Yep. It would run this, it would run this, then this, then this. Then it would run this, then the next one, then this. Runs this every time and this every time.
So is there any function that runs only once for every test? Just like for, say example, like if I am having some kind of a database operation, which is very, or I need to initialize something that uses a lot of memory. I don't want to run that against each and every test, but once for every test. Is it possible to do that?
Ooh, yes. Yes. And
It's like class level.
yeah, I want to say class start or something like that. I'd have to look it up. But yes, definitely. It's the equivalent to init, but for unit tests, I'd have to look it up. But yes. I want to say class start. That's not right, though. Do you want me to look it up or do you believe me? Okay, good.
Yeah, just want to know that.
It definitely exists.
So setup and teardown, those are specifically designed like for that purpose. They're not like stuff that it just knows how to use. Like I think Java uses setup and clean.
Yes, this is very close to Java unit testing.
But it has to be teardown. Like it has to be teardown.
Oh, this name?
Yeah.
Yeah, if you don't name it this, it won't get called.
Okay. You
So,
don't think
yes.
it's a test.
Or nothing. If it doesn't have test underscore in front of it, it's just a method on that class.
Okay.
So it runs all methods that start test underscore, but not other ones that might have like some support function. or something.
Correct.
And if I'm having like 4 or 5 different test methods, all will be running parallelly, right?
Depending on your runner. If we just run this file this way, it's serial. If I use a test runner like nose, that runs parallel tests. So you can set them up to run parallel.
Sorry, just to make sure I understand that little business at the bottom of the underscore name. That's kind of like calling a constructor. It's like when the class is instantiated, that main function executes.
Actually, when this file is instantiated, this name is put into the object that is built from this file.
It's almost like code that's being run from the constructor.
Sure. This will have a value when I run this file, and its default value is main.
It's entry point into the program, so you can run it from the command line.
But that's what this is for, to allow me to run it from the command line.
Test runner wouldn't use that.
Yeah, test runner doesn't use this at all.
Run it from the command line without specifically calling a function.
Yeah, just type in swerve controller test.py, and it'll actually run
So
this.
main in this case is kind of like the constructor, in that when you instantiate the object, that function executes.
Yes, and I'm instantiating this file because Python compiled files are objects, right? So they all have inherent attributes, and one of those is main. Okay. What else we got going on here? Okay, so this answers your question from earlier. Modular approach, be dry, don't repeat yourself. One test file for each module, at least one test per function or method. Test everything within reason. We don't typically test admin.py, which is a Django file, because that's testing the framework. We don't test the framework. Don't test configuration files. I don't have any. If you've got .ini files, you don't have to test those. If you've got .cfg text files, you don't have to test that. Consider testing only fixtures rather than production fixtures. You have no idea what I'm talking about in terms of fixtures, so don't worry about that. Here, common is where I shove all kinds of functions that I use throughout the module. Common has its own tests. Constants is where I put all my text constants. Constants has its own test. Models is where the database models are stored. There's a bunch of classes. That has its own tests. Now here, cache, activity queue, asset manager, each one of these modules has its own test that goes with it. And inside of each of these is probably 20 to 30 tests. Small units, even in your tests. And you'll notice every single file has a test to go with it. Other than this, which is a framework file, and initpy also a Python framework file.
Do you actually push those test files to production?
I push everything. It's all just text files. They're really small in general. You wouldn't necessarily have to, and it would be pretty easy to set Git to not push those, but it's not going to break anything by pushing. And also, it's never going to execute those, so they will never turn from .py to .pyc, so that's good. But now here's why I really like having them there. Your test should run in production. So once you've pushed, you run those tests, you know that software is running in that environment properly. So it's good to have your tests with it.
How would you test a file full of constants?
I was thinking the same thing. What do you test?
That those constants exist.
If they're in scope, you can access them.
Yeah, you could even test for their type to make sure that somebody doesn't set one of those constants inappropriately.
Like if one's a dictionary.
I could come up with a bunch of things I could test. So I would suggest that my constants test is one of the lowest. It has the fewest number of tests in it out of any of my other tests. So yes, but test everything. Don't not test something. A constant really doesn't have any function.
Right, it's not doing anything logical.
However, if it's used everywhere, then it may be really good to test that it's included.
At least usually when we're doing like ActionScript code or something like that, there would be some public functions and some private functions.
Cool.
And so if you're writing a private function, it's only really basically being called by the class itself, not by the outside.
Cool.
But if you've got, I don't know if
Test
the
it.
same thing sets it up that way, but that private function, how do you basically test that when you don't have direct access?
Aha. That's your compiler saying it'll flag as, hey, this is private, you shouldn't be calling this. That's your compiler doing that, right? In Python specifically, all we are is decorating. They're not truly private or truly public. So we can call them directly. In ActionScript, I'd have to research a little bit more, but I suggest you can call them, especially if you're running in a test runner that expects you to call private things publicly. So I actually break that style when I'm testing. I do call private functions publicly when I'm testing. Like I'll instantiate an object and then I will call that private function to private method to make sure it is returning properly. I do that a lot actually. Do you understand?
Yeah, I'm not sure if ActionScript has that, but it's probably worth looking at.
The compiler enforces private and protected and public.
Yes, but you'd
Compiler
be using the Flex test runner. So that might actually overcome that. I'm not sure. Once again, this is Python.
doesn't.
I don't know.
Yeah. Keep me posted, Flash guys.
So you mean to say that in Python we can test the private method as well?
Totally. I definitely do, always. I test everything.
So
And
that's against the object-oriented concept, right?
it's against the object-oriented concept for the production code. I agree. But for your tests, you're trying to isolate your units. And so I'm not worried about that. Wow, good questions. All right, so this is what my environment looks like. This is my test file. So you'll see If you were to go down a little bit more, it'd have the test, unit test object there. Versus the code is actually testing against, which is just models. This is models test. Now, I'm showing you this because I'd really like you to look at Eclipse as your friend. These are my unit tests in this file, and they all run by clicking this button here. It runs all these unit tests. If they all pass, this is green. If any one of these fails, this will say fail, and this will be red. This is it compiling and then running. Ran 13 tests in 2.23 seconds. I have another screen looks just like this. Right? So I clicked this button, which is show only errors, and I caused assert false true. So I guarantee that's going to fail. And here it is, it fails, and it says assertion error true is not false. Imagine that. So I can click this, and it will take me immediately to here. You'll also see, you can't see here because it's a really small screen. Here we go. The text fail, it says fail. Test asset type returns name value and accepts only unique. Assert the asset contains a unique name property. This failed. I can look at this and I know what's wrong because the test name is very explicit. This is why we break style for our test names. This button right here is my favorite thing about Eclipse. If I save this file or that file, it runs all my tests again. On the fly, I don't have to do anything else. Wow, does that save me a lot of time. Wow. Because as I'm programming here, if I break something that I didn't know about, my test will say, hey, what are you doing? On the fly, so I know that something's wrong. Saves me a lot of time. Also in Eclipse, you have pydev, so you can set breakpoints, and those work for tests as well. If you click this debug button after setting a breakpoint and you run your tests, it's going to stop at where you told it to, and then you can look at all the variables, you can see where it came from, why it's doing what it's doing. Really, really, really awesome. pydev, part of Eclipse. pydev on top of Eclipse, not part of. So now we'll do some pro tips. Be disciplined, don't slack off, and stay sane. Build tests first where possible. Small units, think about testing everything before you create it. Modularize breaker code into separate files with a separate test file for each. Right, you saw my Swerve module is huge. It's because I break my units up. Do that. Live sanely. Okay, if you break something, fix it right now. If a test is broken, fix why it's broken and or cause the test not to fail anymore. Don't leave it for later. Bad idea. Name your tests for what they do. Docstring your tests with a statement like assert good stuff. Small change lists. You guys don't know, have any clue what I'm talking about. If somebody is reviewing your code, don't give them 1,000 lines of code to review. You're a jerk if you do that. Try and keep your code submissions relatively small. 20, 30, 40 lines of code, that's a great unit to submit for code review. Submitting large things just means it takes us a long time to review them. Use version control to note changes clearly so it's easier to track down the changes which cause tests to fail. Now, that's the CL number or whatever you're using to track your changes. Oh boy, uh-oh. So now we get to the fun stuff. We want to see if post to URL with data gets the correct data given specific inputs. It returns a URL post response object, right? We're going to test that it returns a post response object. Yeah, right. Are we doomed to make external calls? How do I cause this piece right here not to actually run, and yet I want to make sure that it actually runs? Huh? If I call this, I make a call to the internet. That's not good testing. That's integration testing, not unit testing. Right? I'm just trying to test this unit. Does this unit perform the way it's supposed to? So what would I do? I'd give it a string, and I'd give it some data, and then I'd see if that string and data got passed correctly to this function. I don't care what this gives me back. If I cared what this gives me back, that's integration testing, not unit testing. If I'm testing this unit, all I want to know is, did I give this unit the proper information? It's a little complicated. This is outside of the box for most programmers. So I'm going to show you the tests now. All right, I already set up my mocks here so I can deal with it. Test UID name to some test string, test data, some test data. This is what I expect to be passed to my get URL function. I expect it to be given this. So now what I do is this post to URL with data, I stub it with a mock. What that means is I cause this function to be replaced with a mock object. That way when this function, post to URL with data, is called, it doesn't actually call the actual function. It calls my mock of that function instead. Exactly like that, except on steroids, because I can tell how many times that was called. I can tell what it was passed. I can even tell it what to give back. So I stub it out. So here we are, post URL with data, and here's what I expect it to use. Dashboard URL and expected dictionary. And then I say replay all, which turns on all my mocks, and then I make the call. Create update swerve asset, which is the name of that function if you go back. Create update swerve asset. Create update swerve asset, so I call it. And I don't have any additional tests here because I don't need them. Because if I don't call post to URL with data with the proper information, it's going to fail. Now, I would actually add some additional tests in here, but I'm just talking about the mock object here because it's really kind of hard to grasp. I'm going to go back a screen and discuss the function again, and then we'll come back to this and look at this one more time. So I'm going to go back. I'm giving it fake data here. I'm giving it fake data here. And then I'm saying, are you calling with that fake data? Now, it does other things as well, obviously, but ultimately, I'm looking for this information because I'm testing whether this has been called or not. You could, in theory, mock this, and this, and this, and this. 1, 2, 3, 4 different mocks, and verify that each one of those was called with the correct information. That would be awesome. I'd give you an A+. Good job. Well, see some blank looks. It's not good. Okay, so here we create our fake data that's going to be passed to it, and then we say, this is what I'm expecting out. Then I mock out the function, and I say, this is what you're going to be given. If that is actually what it's given, this test gets a green light. If this is called more than once, if this is called with different data, this test will fail. And it will fail explicitly, saying you called it with this when it should have been called with whatever, or you called it with this when you should have been calling it with this. So it's very explicit mocks.
So you're asserting the inputs into that. That's what the test is about.
Yes. Just that unit. What goes in and what comes out.
I thought you said you don't care what comes out.
Well, in this case, you're right. So I would probably restate that, but this is the final thing that is returned. So
Okay.
that's why I said it comes
Right.
out.
Now, what happens if it was supposed to be called 5 times? How do you represent that?
Very good question. Mock it once and then put this 5 times.
Oh, I see.
Do you copy, paste, copy, paste, copy, paste, copy, paste. 5 times. I just did that this morning for inventory because there are 4 items per inventory award, right? So I needed 4 of the same mock.
You cannot have just 5 times. Just like 5 times that.
No.
No.
I could put it in a for loop. For I in range 0, 4, comma 1. That would work.
The assertions in the verify all.
Oh, here. There are no assertions here. I did that on purpose. The mock is enough. Now, if I was to really be thorough, which I probably should be, you'd put a result equals and this, and then test the result that you get back from it to make sure that you got what you're looking for. But because we're mocking this out, what I get back from it would be nothing. So it's really kind of pointless. As I said, we could test each of the other pieces for what goes in those, so you can watch the variables as they pass through, and you can mock each one of those as well, and your test will grow and grow and grow as you mock more and more things.
So the verify all is doing the assertions inside.
Yeah, replay means activate these stubs, and verify says, was this called? And if it wasn't called, then it throws. That's what these two are. And this is, once again, I'm using the mocks library. There is a MOCK, unittest.mock, that is different than the mocks library that I'm showing you here. This is Google's standard for unit testing. Everything's standalone using the mocks library. You can use the mock object in unit testing. That's totally okay. See what else I have. Go ahead. Heard you ask something. Ooh. Yeah, we'll deal with Django here in a minute. What's a unit?
Function?
Small part, the smallest piece you can. What's a unit test?
Test for the smallest.
Yes, test for the smallest thing you can. Assert. Yeah, it's okay. Workflow, modular, look in pieces. Write your tests first. Use Eclipse. If you're not using Eclipse, I want to hear what else you're using because I'd like to know. What do we test?
Everything.
Everything. Every single line of code needs to be tested. Nothing is to be missed if you are to have complete tests. Can you have partial tests? Yes. Can you have crappy tests? Yes. So, yeah. Questions?
Do you have any tool for finding the code coverage?
Yeah, coverage.py. Pip install coverage.
And are you shooting for 100%
Actually,
coverage?
it comes with lint, I believe, coverage. Anyway, yes, coverage.
Are you shooting for 100% coverage? Or
That would be ideal. Good luck. Our time is up. I knew this one was going to be intense. Next week, Django. And I will do that from a test-driven development perspective. So you'll see a lot of tests coming up here shortly. Anything else? Have a nice day.
yes.